Hi, my name is Deepshika Banerjee. I'm based here in St. Louis, Missouri, and welcome to our sixth and final module in the micro course, Introduction to Neuroscience, Current Implications of Neuroscience. So, a few things we're going to go in this last module. We'll be exploring a few neurological and mental health disorders, learning how scientists study the living brain, discover emerging neurotechnologies, understand a few ethical challenges in neuroscience, and review a few key concepts from this course. So let's start with neurological disorders. Neurological disorders affect the brain, spinal cord, or nerves. Symptoms really just depend on the affected nervous system region, and causes include everything from genetics to injury to infection to degeneration. Early diagnosis more often than not helps to improve treatment outcomes, and current research is being done to continue to advance new therapies to help in the fight against neurological damage. A few commonly known neurological disorders include Alzheimer's disease, which is a progressive memory and cognitive decline, Parkinson's disease, which is a movement disorder caused by a loss of dopamine producing neurons, epilepsy, which is the occurrence of recurrent seizures that are caused by abnormal electrical brain activity, and strokes, which is the interruption of blood flow to the brain, and requires emergency treatment. So treatments for these disorders commonly focus on symptom management, rehabilitation, and just improving one's quality of life, especially with conditions like Alzheimer's and Parkinson's. Now, mental health is also connected to neuroscience in a way. Mental health conditions involve changes in brain function and behavior. Brain circuits, genetics, and environments all contribute to it. Common conditions include that also have foundations in brain sciences include anxiety disorders, depression, and schizophrenia. Treatment for such these may include psychotherapy, medication, lifestyle changes, or a combination. Reducing stigma in this field encourages for earlier diagnosis and support. So in a way, that can be considered a treatment option as well. Now, we've stated before that researchers and scientists have been using different ways to study the brain, the nerves, the spinal cord as a whole. To dig a little bit deeper into these methods of study, we can look at a few different scanning techniques. These include the MRI, which produces detailed images of brain anatomy, fMRI, that measures changes in blood flow linked to brain activity, EEG, that records electrical activity using scalp electrodes, PET scans or images that show brain metabolism and molecular activity. More often than not, researchers are combining several of these techniques to answer a vast variety of questions. An emerging neurotechnology in the field currently is a BCI, or a brain-computer interface. So BCIs translate brain activity into a computer command. It can help restore communication and movement and is used in assistive technologies and rehabilitation. Current research is aiming to improve speed, accuracy, and accessibility to such devices. BCI remain an active area of neuroscience and engineering research to date as well. Now, AI and neural networking have a huge part in neuroscience as well. AI was in fact inspired in part by how neural networks process information. Since AI is general intelligence, it was built to attempt to mimic organic intelligence, which is produced by our neural pathways. Neuroscience helps to improve brain inspired computing within different AIs. Currently, AI can also help to assist in analyzing brain imaging and large data sets as well. Machine learning supports disease detection and research in different ways. Now, while AI does complement human expertise, it has not been able to replace it. There's also a lot of ethics within neuroscience and people who are working with it, regardless of whether it's in technology, engineering, research, or computer science, or any field in general. A few base rules that have to be maintained at all costs include protecting patient privacy and brain data, ensuring informed consent in research, promoting equitable access to new neurotechnologies, considering the risks and benefits of cognitive enhancement, and using neuroscience responsibly in medicine and society. A few careers that are still up and coming in neuroscience include those of neuroscientists, neurologists and neurosurgeons, neuropsychologists, biomedical engineers, data scientists, AI researchers, and neurotech specialists. So, in this course, we've learned a few different things. First, neurons communicate through electrical and chemical signals. Brain regions work together in interconnected networks. Learning changes the brain through neuroplasticity. Neuroscience improves medicine, technology, and our understanding of behavior. And curiosity and continued learning drive further discoveries. Thank you so much for joining us for our first micro course in the Introduction to Neuroscience.